Okay, good evening. So let's first finish our discussion on normalization. Okay, so then we'll do a 2024 past paper. Okay, right. So last time's recording was not done properly, so therefore I shared you the previous batch recording. Okay, up to that point. Okay, so remember the data normalization is making your database consistent, less redundant. Okay. So either you do your design and then check the normalization, or when you are familiar with normalization, naturally, when you do the designing, you will design normalized database. So that is what usually happens, right? But initially, maybe you do it as a post design check, right? Right. So remember the two concepts are the atomicity and dependency. So we discuss what is atomicity. Atomicity means it must be only single value. Every field for a given record, it must be a single value. For example, you can't have skills as a field, contact numbers as a field. Okay, right. So then functional dependency. What is mean by A functionally determine B? Okay. So if you know A, if you can derive B uniquely, so then we say A functionally determine B. For example, if I know the ID number, I can say the name, but not knowing name, I can't tell the ID number because same name can be for different people, but you're supposed to have only one ID number. Okay, one ID number. I think last week there was a code decision also, right? Appeal code decision that one of the politician's wife having fake ID number and 2 years imprisonment, right? So therefore, when we know the ID number, it must be unique. Okay. So then we look at the Armstrong axioms. That is, A functionally determines A. If A determines B and B determines C, A determines C. So those are the two most important for us. Okay. Other than that, we have A determines B, A determines C means A determines BC. A determine B, then AC determine BC. If A determine BC, then A determine B and A determine C. But for us, most important are these two. Okay. Right. Reflexivity, transivity, then for the union, augmentation, and so on, but projectivity. But the first two are the most important. So then we discuss how to find exclosure and exclosure. Okay. Exclosure and exclosure. For example, if you are given set of dependencies, you can find F closure. That means all the dependencies. A determine B, B determine C. Therefore A determine C also, right? And of course A determine A, B determine B, okay, and C determine C. So all the dependencies, if you list down, that is called F closure. Right? Exclosure is for a given value, what are the things that it determines? For A, then you can find A closure, B closure, C closure, D closure, E closure. Okay. So A determine A by reflexivity. Then it says A determine D. Then D determine B, therefore A determine B. And then B determines C, therefore A determines C also, and so on. Okay. So if you take something like C closure, C determines C by reflexivity. But there's no where you have C in the left side. So therefore nothing else is there. So therefore C determines only C. Right? If you take D by reflexivity, D determine D. So then D determine B. And B determines C, therefore D determines C also. So that's it. Nothing else. So that is called exclosure. Okay. So I hope now you have pretty much familiar with that. It's super simple concept. Okay. Now let's elaborate our discussion to formally define what is primary key using functional dependency theory. Okay. Formally define. Right. So according to functional dependency, the theory of functional dependency or functional uh, relational algebra, okay, candidate key is minimum set of attributes that fully functionally determine all the attributes of that relation. So what is candidate key according to this definition, abstract definition? Right? Minimum set of attributes that fully functionally determines all the attributes is called a candidate key. Right? So I don't know whether you get anything out of that statement. Most probably no. Right? When you first read it, most probably you will not get any meaning out of that. But let's take an example. Say these functional dependencies are given. Right? We are given these functional dependencies. Right? So these are the fields. A, B, C, D, E. Those are the fields in a relation. Okay. A, B, C, D, and E. So then we will have tuples for these five fields. Right. So now first we want to find X closures. That means A closure, B closure, C closure, D closure, E closure. And thereby derive possible candidate keys. So that is the second part. Okay. So let's do the first part because that we have done already. Right. Can you take 1 minute and do it? Find the X closures as exercise. Right. Quickly do it. Because you have exams in about 1 month, right? Right. So let's find A closure. A determines A by reflexivity. You can use Armstrong axioms. And A determine D, and D determine B, therefore A determine B, and B determines C, therefore A determines C also. Transitivity. That's it. That is A closure. So what about B closure? B determine B by reflexivity, and B determines C, and that's all. C closure. C determines C by reflexivity, and that's it, because C is not in the left-hand side of any of these. D closure. D determine D, and also D determine B, and B determine C, and that's all. Final one, E closure. E determine E by reflexivity, and E determines B, and B determines C, and that's it. Okay. So these are the exclosure. So that is our first part. Okay. Right. So now what we need to do is we want to now these are the exclosure. Now our final task is derive possible candidate keys. So what is the definition of candidate key? If the minimum set of attributes that fully functionally determine all the attributes of that relation. Right? For example, if you take A only, A determines A, B, C, D, but it doesn't determine all the attributes because E is not there. So therefore, A is not a function candidate key. B determine only B, C, therefore B is not a candidate C key. C determine only C, therefore C is not a candidate key. D determine B, C, D, not a candidate key. E determine only E, B, not a candidate key. So what is candidate key? The minimum set of attributes that fully determine all the attributes. But this is almost there, A, B, C, D, but unfortunately E is not there. So therefore A alone is not a candidate key. But what about if you introduce E also? Remember E determines E. Now, therefore, AE determines A, B, C, D, E, everything. And we have two fields. Remember, you don't have single field candidate keys. So then we need to check whether two field candidate keys are there. Yes, this is a candidate key. Because first we check whether there are single field candidate keys. No, because A almost there, but it doesn't determine all the fields. Therefore, we had to introduce another field. Try to make it minimum. So therefore, we just introduce E because E is the one that was not there. So then E determine E by reflexivity. So therefore, AE determines the entire set of fields. So therefore, AE is a candidate key. So there can be more than one. Okay, more than one candidate key. For example, if I introduce maybe A here, now remember B is not a candidate key, right? Maybe if I introduce A here, then A determine D. D determine B, B is already there, B determines C already there, and that's it. So therefore, BA is also not a candidate key. Likewise, you can check, right? Anyway, always you can see that E must be there because uh, E is not in the right hand side anywhere. E is not in the right hand side. So therefore, E must be in the candidate key. So therefore, this should be the minimum, right? Because E must be always there. එතකොට මේවට E කොහොමද දාන්න වෙනවා? එතකොට E දැම්මට මේක පිරෙන්නේ නැහැ. ඒ කියන්නේ මේක තවත් දාන්න වෙනවා. ඒ කියන්නේ ඒකට දෙකකට වැඩි එනවා. දෙකට වැඩි වෙන වැඩක් නැහැ. මිනිමම් නේ හොයන්නේ. So therefore, this should be the candidate key. So this is another way of finding candidate key. A very formal approach, right? Right. So therefore, A is the minimum. A is the minimum. So therefore, A comma E is the candidate key. Is it clear or not clear? Okay. So you need to keep adding fields until you have all the fields in the bottom. But make sure you are looking for the minimum. If there are two or three combinations of the same size, then all are candidate keys because you can have multiple candidate keys. So in then, what is your primary keys? That is your decision based on business usages and so on. Okay. Right. So now we move on to now the theory part is over. Now we move on to normalization of data. So this is now we are getting back to more practical. So far it's like a theory. Now we are getting back into the database, the real world database concepts. Okay. Right. So remember, normalization is a sequential process. Right. So that means first we check whether it's first normal form. If not, we need to make it first normal form. Once it is in the first normal form only, you can check whether it's second normal form. If it is already second normal form, so then you can check whether it's third normal form. If not, make it third normal form. So then you can think of BCNF and so on. Okay, so you should actually there's something called fourth normal form also. But in general, if the database is in third normal form, we consider it as a good design, right? But in some special cases, we consider even the BCNF also. Okay, very rarely we look at the fourth normal form, so therefore we don't even look at fourth normal form. Okay, so in general, when it is in the third normal form, we say that your database is normalized. That means fairly good in integrity and very little redundancy. Okay, right. So therefore, it's a sequential process. Right. So you can't check second normal form without checking first normal form and make it first normal form and so on. Okay. Right. So what is mean by first normal form? It's super easy. The first normal form, we say that a table is in first normal form or the relation is in first normal form if all the attributes are atomic. So remember the two concepts are atomicity, functional dependency. If all the fields are atomic in your relation, so then we say it's in first normal form. If at least one field is not atomic, we need to make it atomic. We need to restructure the tables so that all the fields are atomic. So then we can say that, okay, this particular relation or table is in first normal form. It's super simple concept. Okay. Right. If a particular field is not atomic, what is the solution? So you take that field to a separate table and create a one-to-many relationship where that new table is the many side. So that makes sense. Okay, that makes sense. If it doesn't make sense yet, when you look at the example, it will make sense. Okay. Right. So this is a table someone has designed. Customer ID, name, contact numbers. So obviously customer ID is atomic. Like you can't have two customer IDs for one customer. Name, let's assume you don't have any two numbers. Right. ගෙදරට ගිය නම දාන්න යෝ උපැන්න සාතිගේ නම විතරයි කියලා හිතමු. So then just one name, fine. But you can see contact numbers field. So you can see already there are multiple values. So this is not atomic. This is not atomic. So that means this has violated the first normal form. Okay. So these two fields are okay. So therefore now we need to know, make it first normal form. How to make it first normal form? Remove this field and take this field to a separate table and make a one-to-many relationship with this one. So therefore many side is going to be the new table. So therefore many side is going to have the foreign key, which is this one. Okay. So this is the solution. So we have the customer table, but we have get rid of contact numbers because otherwise it's not in first normal form. And we have taken the contact numbers into separate table. Right? For that, we have introduced primary key called contact ID and also the foreign key because this is one to many, one to many. One customer can have many contact numbers. Right? And for each customer ID, so these two are now two records for customer ID 1. Right? So these two are two records for customer ID 3. And it's now one-to-many relationship. And this is your foreign key. Okay. So now it's first normal form because this table is every field is atomic. This table also every field is atomic. Now you don't have multiple values for contact number. Rather, it will be multiple records. Is it clear? So the problem, the solution. Okay. Right. So this is another example. You can see that this table is also not first normal form because this is fine, this is fine, this is fine. The price is atomic. You can't have two prices for one product. Okay. And you can see there are multiple colors. Right. Alto, white, black, and blue. White, black, and blue. Maruti, white and black. So that is violating the first normal form. So therefore, maybe those are same price, but different colors. So therefore, now we need to take this to a different table and create a one-to-many relationship. Okay, so that will make those two tables both in first normal form. Okay. So we can introduce our surrogated key also like product color ID or something because you need a primary key for table because this is not going to be primary key because duplicates. Or you need to make combination as primary key A better thing is introduce your surrogated key. So now you know that alto, you have white, black, and blue. Maruti, you have white and black. For Panda, you have only white. So same thing, but now in a much better structure. Now our two tables, yes, we have introduced another table, but now the two tables are in first normal form. Right, so this is another violation. This violation can happen in different ways because maybe the designer has done a mistake. Right? So this is the same problem, different symptoms. Right? එකම ප්‍රශ්නේ තියෙනකොට වෙන රෝග ලක්ෂණ මතුවෙනවා. So this guy has defined two fields called qualification 1 and qualification 2. So then someone will ask, what happens if you have qualification 3? Qualification 3ක් තියෙන කෙනෙක් ආවොත්? Qualification 5ක් තියෙන අය ආවොත්? ගොඩක් දාලා තියමු කියයි එතකොට. එතකොට කියන්නේ එතකොට qualification එක තියෙන අය හැමතිස්සෙම මෙතන null value නේ. Storage අපරාධය. So therefore, this is again the same problem, different symptoms. Again, not in first normal form. That is why this guy has introduced qualification 1, qualification 2, and so on. So this is not the solution. This is a fake solution. So let's fix this. Get rid of this and put it into another table and create a one-to-one relationship. Okay. Make sure the employee ID is a foreign key. Now we know that employee ID has BSc and MSc qualification. Employee 2 has the BCom qualification. And employee 3 has CIMA and BSc qualification. And if you have another qualifications, another record. So another record is fine. So this is another example where violation of first NF and the solution. It's a one-to-many relationship. Okay. Right, so let's move on to the second normal form. Now you know how to identify violation of first normal form and make it first normal form. Right. Right. Second normal form. So remember you check whether relations or set of relations are in second normal form after verifying that it is in first normal form, or else you have make it first normal form. That is what is meant by sequential process. Right. Second normal form and above are related to functional dependencies. First normal form is related to atomicity. Okay. Right. So this is the definition. A relation is in second normal form if it is in first normal form and every non-key attribute is dependent on the whole of the key, not just part of it. Not just part of it. Or in very simple terms, we say no partial dependencies. KTM no partial dependencies. So this is mostly important when you have composite primary keys. But they will have a problem with any composite primary keys. Right? So if you have a non-key field, that non-key field must depends on the full key. If you have multiple composite key, so it must depends on the full key, not just part of it. If a field depends on part of that, that means your table has violated second normal form. But if a field depends on the full key, that is fine. Next field also depends on the full key, that is fine. So that means it's in second normal form. If you find a field that depends on a single field, whereas your key is multiple fields, that has violated second normal. Okay. So problem and the solution. What is the solution? So the solution is if a field depends on part of the primary key, where you have composite primary key, so that means that field should not be here. That field must be taken to the relevant table. This is not the place to keep this field. You have made a mistake. You have made a design error. And it's pretty much common sense. ටිකක් කල්පනා කරාම ඔක ලොජික් එකක් විදිහට ඔයාලට තේරෙනවා. ඔව් ඒක එතන පොඩි නෙමෙයි අවුලක් තියෙනවා. ඒක විසඳන එක තමයි හරි කියලා. So let's take an example. So this is a table where we have composite primary key, student ID, course ID. Maybe student can register for many courses, course can have many students. Maybe this is a connecting table for many to many. Remember connecting, when you introduce connecting table, it becomes two one-to-many relationships. Two one-to-many relationships. So these are the other two fields for this table. Someone has designed this, okay? Now see, these are the non-key fields. You need to take one by one and check whether these non-key fields depend on the full key or part of it. If it depends on the full key, that is fine. If it depends on just part of that, that means this should not be here. It has violated second normal form. Okay. Right. If you take payment, now look at the meaning of this payment. So this payment is done by the student for this course. Student 1, for course 1, the payment is 30,000. Student 2 for course 1, 20,000. Now you can see I can't explain it without referring to both. So that means this depends on the full key. Full key. Therefore, this is perfectly fine. What about course name? If course ID is course 1, course name is BIT. So now do I need to refer to the student ID? No. If course name ID is course 1, course name is BIT. If course ID is course 2, course name is BCS. If course ID is course 4, it's SIMA. Course 1, it's BIT. So therefore, this field definitely depends on only course ID. It has no connection with student ID. So then why you are keeping it here? Right? So these fields must depends on the full primary key, not part of it. So actually this should go into where? Course table. Course table where course ID, course name, course fee, and those things should be there. Course starting date. So therefore, this should not be here because this only depends on course ID. This has no connection with student ID. But payment, yes, because payment by this student for this course. So therefore, now you need to take this to the student table, sorry, course table. Uh, Actually, this should be in course table, right? Course name must be in course table, not here. So then it solve your problem and then it will be in the second normal form. Okay. So this is the solution. We have taken out the course name and we put it into the course table where course ID is the primary key. Right. Now we have only one field which depends full of the full key, full composite primary key. Is it clear? This is not rocket science. This is very easy concept once you understand. Right. So now we move on to third normal form. Again, what is mean by third normal form? If violated, what is the solution? So in short terms, we say no transitive dependencies. For second normal form, what is the short name? No partial dependencies. Here, no transitive dependencies. කෙටි එකෙන් තමයි ගොඩක් අයට අපිට මතක හිටින්නේ. ඊට පස්සේ දිග definition එක ඔයාලට හදන්න පුළුවන් ටක් ගන්න. Right. A relation is in third normal form if it is in second normal form and you can sequential name again. Each non-key attribute or non-key field is directly depend on the primary key. Directly, the word directly, not indirectly. Or indirectly කියන එකට තව නමක් තමයි මොකද්ද? Transitive. Transition එක කියන්නේ කොළඹ ඉඳලා ඩුබායි ගිහලා ඩුබායි ඉඳලා තමයි ලන්ඩන් යන්නේ. ඒතර direct කියන්නේ නැහැ ඩුබායි. මෙතන transit එකක් තියෙනවා. The transitive dependency එක කියන්නේ මෙතනට depend වෙලා එයාගෙන් තමයි මෙයාට depend වෙන්නේ. එහෙම ඒවා වෙන්න බෑ කියලා තමයි කියන්නේ third normal form එක. So your non-key fields must directly depends on key, not transitively depends. That means this depends on a non-key and this one depends on the primary key. That is violation of third normal form. All your non-key fields must depends directly depends on the primary key, whether it's single key, simple key, or composite key. So those violations again you need to fix it. How to fix it? You take that field having transitive dependency to the relevant table. එයා මෙතන නෙමෙයි ඉන්නෝ නැත්තන. මෙයා ඉන්නෝ අදාළ table එකට ගෙනිහිල්ලා දාන්න. අදාළ table එකට ටක් ගාලා වලට අහු වෙනවා. හරි violation එක දැක්ක ගමන්. Right. So this is an example. So this is book table. Primary key is book ID. So we have book name, publisher ID, contact number. Okay. So clearly book name depends on book ID. එක book ID එකට තියෙන එක book name එක. It directly depends on book ID. Remember, non-key fields must depends directly on the primary key. What about the publisher ID? Yes, for one book, there's a one publisher, right? A for the publish karbu publisher. Okay. So that is also fine. That is also fine. Okay. Because we have the publisher depends on book. So far, so good. What about the contact number? So does this contact number depends on directly book ID? No. Actually, this is the contact number of the publisher. පොතකට contact number එකක් තියෙන්න බෑනේ. කම්පෙර්ලි contact කරන්න කියලා පොත number එකක් දෙන්න පුළුවන්ද? එතකොට මට කම්පෙර්ලි contact කරන්න පුළුවන් කියලා. Actually, this is the contact number of the publisher. So therefore, this depends on the publisher and publisher depends on the primary key. But that is not good. So that this is a transitive dependency. Your non-key fields must directly depends on the primary key. But this is not directly dependent. This depends but transitively. So therefore, this violates the third normal form. So the solution is, right? So you need to take this to the publisher table. Publisher details when a table එක යන්න ඕන. This is fine. මෙයා ඉන්න කවුලක් නැහැ. As a foreign key. හැබැයි මෙයාගේ ඇතුලේ මේ publish දැන් මේ වෙලා තියෙන පොත්වල details උයි publisher ගේ details උයි ඔක්කොම එක table එකකට ගහලා. එහෙම කරන්න බෑ. මේක කතන්දර දෙකක්. Publisher details must be in publisher table. Book details must be in book table. මේ book table එක අස්සට publisher ගේ details ඇවිල්ලා. Publisher ID එක තිබුණාට කමක් නැහැ. Otherwise you can't relate book to a publisher. But having contact number is wrong. So therefore the solution is introduce another table called publisher. And there you can have primary key, publisher ID, maybe even publisher name, additionally දාලා තියෙන්නේ, and the contact number. Here you just have the publisher ID. Publisher ID. So now it's in third normal form. Okay. Is it clear? Now, if you are a critical thinker, you might ask another question. Right? You can ask a question. Critical thinkers la ඉන්නවා විචාර බුද්ධියක් තියෙන අය. What is that question? කාටද කියන්නේ whether contact numbers ගොඩක් තියුණා. මතකද කලින් contact numbers කියලා තිබිලා. මොකද publisher එකත් contact numbers ගොඩක් තියෙනවා. ඔව් එහෙම වුණොත් මේ contact number එක ගෙනියන්න තව table එක. Okay. So create a one to many with publisher and contact numbers. So then book has a connection with publisher. Publisher has a connection with new table called publisher contact numbers. Here we assume that only one contact number is there. Okay. එහෙම වුණොත් මෙතන නවත්තන්න පුළුවන්. නැත්නම් මේක මෙතන තියන් ඉන්න එකත් වැරදි. මෙයා යන්න ඕන තව table එකකට one to many විදියට. Right. So in real world soft database designing, usually we consider only up to third normal form. එතනින් එහාට සාමාන්‍ය අපි හිතන්නේ නැහැ. හැබැයි ඔයගොල්ලන්ගේ note එකේ boycott normal form එකක් කියලා තියෙනවා. ඒක බොහොම කලාතුරකින් ඕන වෙන කතන්දරයක් සහ අතිවිශේෂ දෙයක්. Sometimes we call it the 3.5 normal form because There's another normal form called fourth normal form. Anyway, we are not interested in fourth normal form. But in your syllabus, they have mentioned about the boys code normal form. ඉතින් මේ ගොඩක් අයට කියන්නේ 3.5 normal form කියලා. මොකද fourth එකට වඩා කලින් එන එකක් ගන්න. මේක this is a very special case. හරි මේක ටිකක් තේරුම් ගන්න තිය අමාරුයි වාට එකපාරට. So what does voice code normal form says, because it's mentioned in your syllabus, එක අහලම නැහැ කවදාවත් එකම paper එකවත්. Each attribute must represent a fact about the key, the whole key, and nothing but the key. බලන්න ලස්සන කවියක් වගේ. Okay? ඕක වෙන වෙන විදිහකට කියන්න පුළුවන්. හරි. ලස්සනට definition එකක් දීලා තියෙනවා. මම ආසයි chat GPT එකෙන් අහන්න එයා කොහොමද මේක explain කරන්න කියලා. හරි. සමහරට එයා වෙන විදිහකට explain කරයි. නමුත් ඔයාගේ විදිය පොතේ තියෙන විදිය හරි ලස්සනයි. Define voice code normal form. මොකද මේක define කරන්න හරි අමාරුයි. එයා ටිකක් details වලින් explain කරනවා. Help reduce the data redundancy, blah blah blah. A relation is in BCNF if for every non-trivial functional dependency x determined by x must be a super key. එයා වෙන විදිහකට කිව්වේ. හරි. අර nothing but the key කියලා කතන්දරින් කිව්වේ ඕක තමයි. හරි. So if some attributes determine other attributes, then the determining attributes must uniquely identify every row in the table. Every determinant must be candidate key or super key. Okay. Right. ඒකත් බොහෝ විට තේරෙන්නේ නැති වෙති. බය වෙන්න එපා. කොහොමද 3.5 එක පොඩ්ඩක් ඔයා කල්පනා කරලා database එක සෙල්ලම් කරනකොට තමයි තේරෙන්නේ. හරි. ඒක අනිත් එක එච්චර වැදගත් නෑ. අපි software develop කරද්දී නම් 3.5 අපි හිතන්නේවත් නෑ. හරි. Right. Anyway, just remember the definition, right? Each attribute must represent a fact about the key, the whole key, and nothing but the key. Okay. Right. So let's take an example. So this is a table that has violated boycott normal form or 3.5 normal form. So this table has three fields: student, course, instructor. Okay. Now let's say we have some data. Data ටිකක් මේකට දාලා බලන්න. Right. Say we have student called Nimal, course called BIT. For that course, say it's individual classes or something. For Nimal, for course BIT, instructor is Kamal, say Ravi. So there's another student called Amal, FIT. The instructor is, say, Rohan. So if you have something like that, right? So this is our table. Assume there's no other table. Now what's wrong with this? What's wrong with this? Now what's wrong with this is, now if this is the only table, say we have a new instructor, right? Other than Ravi and Rohan, we have an instructor called Rehana. If Rehana is not assigned to a student, Rehana's data will not be in this table. So that means there is no place mentioned about the instructor called Rehana, because instructor is not a part of the primary key. If a student is for a student, for a course, if that instructor is assigned only, there will be a record here. You can't say null, null, and Rehana. Remember, primary keys cannot be null. So that is a problem. So therefore, this has violated BCNF normal form, boycott normal form. So the solution is, again, instructor is a different concept. So therefore, instructor must be into the instructor table. And here you should have only the instruct ID. as a foreign key. Otherwise, you don't have instructor details in a separate place. Okay, so uh, this is the solution. Okay, so here we have student course. ඇත්තක හරියටම කරනවා නේද instructor කියලා තියෙන instructor ID එක තමයි. හරි. So therefore we have instructor is assigned to course and also instructor is assigned to student. Okay. මේක වෙන විදිහට කරන්න පුළුවන්. තව විදිහක් තමයි student course and instructor ID and then instructor ID and instructor name. එතකොට instructor කෙනෙක් student කෙනෙක්ට assign නොකරත් instructor ගේ table එකේ instructor. Okay, so don't think too much about BCNF because it's very rarely we use BCNF and very rarely BCNF is relevant. Okay, very rarely. Right, so the next concept is denormalization. So remember, normalization is good because it makes the design much stronger, solid, and it reduces anomalies. But remember, most of the time when we do normalization, we introduce more and more tables. More and more tables means more and more joins in queries. Right? Because you need to do joins. Right? Join book with publisher, publisher with publisher contact ID to get the contact details. To get details about a book, 3 tables you need to join. So therefore, sometimes, not always, we do denormalization. For example, say, ideally, yes, publisher details must be in the publisher tables, not book table. But for performance reasons, maybe we will decide, okay, let's keep publisher details or the publisher contact ID also with the publisher book table. Knowing that we have violated, say, third normal form. So that is called denormalization. Right? Sometimes, yes, we know that this has violated this particular normal form, but we just keep it as it is for, especially for query performance reasons. That is, knowing the consequences, we violate it, but not always. Especially when you have a lot of performance concerns and so on. Okay. So then we say it's called denormalization. Denormalization. Mainly we do denormalization for performance reasons because these joins can be very costly when your data table has thousands and thousands of records. Okay. So if you do like that, or if you keep unnormalized relation for a purpose, so then we say it's denormalization. Right. So this decomposition is not directly mentioned in your note, but I added it as a note, our note, because about 5, 6 years ago there was a question. Okay, there was a question, but afterwards examiner has not asked any question, so therefore I will not do this. Okay, you can simply ignore this part, but I just kept it. If you are interested, right, about this, you can just read it. Maybe you can look at some YouTube records and so on, but I'm pretty sure they will not ask this about the decomposition in your exams. But if you have time after doing the past papers, maybe I will do this, right, taking about half an hour. Okay, but we are not going to do it right now because it's little bit of another tricky area like BCNF. Okay. Uh, so therefore, I'm not going to do it right now. And also, they have not asked any of such questions for the last 3 years, last 3, 4 years. Okay. Right. So I'm not doing this past paper question because anyway, we are now going to do some past paper questions. Okay. Anyway, let's do the past paper questions. because these are some old questions, okay? No, we'll straight away do the past papers, okay? Right, so we'll take a small break. After the break, we'll do 2024 paper, okay? Uh, right, we'll take a small break because we are going to do until only 9, okay? So therefore, we'll start at 8. Uh, so let's move on to our first paper for database 2024, okay? So make sure you read the instructions for each and every paper separately. This one says only one answer, right? Only one correct answer, right? Right. So therefore, it's easier. Usually, one answer means easier. Okay, easy paper comparatively. Right. So let's take one by one. Which of the following is true about entity integrity constraint? So remember, entity integrity constraint says your primary key must be unique and not null. Mainly not unique. Okay. not null කියන එක ඊළඟට එන්නේ ප්‍රධාන දේ තමයි unique කියන එක. Right. The primary key value can be null. No, it can't be null, right? It must be not null. So that is definitely no. Okay, definitely no. Every entity must have a unique identifier. Yes, identifier means primary key. Your primary key must be unique. So that is what entity integrity constraint says. Entity integrity constraint has nothing to do with the foreign key. Primary key must allow duplicates. No. Composite key is a column that uniquely I didn't know. That has nothing to do with the entity integrity constraint. So the answer must be B. Primary key must be unique. Okay. Yes, answer is B. Second one. Who is responsible for authorizing access to a database? Right. So usually a database is under database administrator. Right. Database administrator. The operation of the database is under database administrator. So it's not data administrator, database administrator. So the answer must be E. Right? E. Third one. Which type of data manipulation language, DML, right? DML means insert, update, delete. Select is DQL. Then create, alter, drop. Those are data definition language. Which type of DML allows user to specify what data is needed rather than how to get it? Right? So that is basically what data is needed rather than how to get it is sorry. Remember the first generation languages, second generation. First generation is machine code, second generation is assembly code, third generation is procedural, fourth generation is you tell what to do, not how to do. Right? So that is more declarative. Okay. Uh, not procedural. Okay. Procedural means you tell the procedure. So therefore, I do now it's little bit confusing. So it should not be low level, right? Not low level. Not procedural. Procedural means third generation. Remember, SQL is not procedural. Fourth generation. Non-procedural. Transactional DML. No. Query builder, I don't think so. So it's not procedural, right? It's declarative. So therefore, maybe non-procedural. But the better term is declarative. But declarative means you declare what to do rather than tell how to do. So then we will go for non-procedural because this is the closest out of these 5 answers, right? E. Yes, third one E. Okay, third one E. Right, fourth one. What is the primary purpose of relational algebra in the context of database? Right, remember relational algebra is the theory behind manipulation of data in relational databases, right? Sigma, pi, joins, right? Sorry, Cartesian product, joins, left outer join, right outer join, inner join, okay? Union, okay? Right. What is the primary purpose of relational algebra in the context of database? To format database reports, definitely no. To define mathematical operator for querying relational data. In a way, yes, right? Mathematical, yes, like mathematics. Maybe. Let's keep. To enforce referential integrity rules, no. To store data in tabular form, no. To perform, no. Yeah, so this is the best answer. We'll settle for B. Okay. Yes, B. Fifth one. Which of the following attributes is derived from other data? Right? Age. Age can be derived from date of birth. Answer is D. So far, it's an easy paper, right? So far, I don't know. This is the first time I'm looking at this paper because this is 2024 paper. I never got a chance to go through this paper. I'm also looking at this, just like you are in the exam, I'm also looking at this paper. Of course, other papers I have done at least once because I forget to have a look at this paper before the class, okay? Sometimes I go through the paper, but this one I forget, okay? The degree or arity of the following relation is, maybe that's another name for degree. This is the first time I saw this word. We know what is degrees. The degree of the following relation is, right? So what is mean by degree of a relation? Right? Degree of a relation. Is it number of fields or number of records? It's number of fields, right? Yeah, number of fields. Right. So then it's a relation, not relationship, right? Flagship store, it has store ID, a department count, exclusive item count. So that means we have three fields. So three fields means the degree is three. This within bracket it's a primary key, but it's one first field, second field, third field. So I'll go for D. Six, I'll go for D. Yes, D. Okay. Degree. Seven. Which of the following SQL command syntax is utilized to define a foreign key with referential integrity that sets the child value to null when the parent is deleted? So that is on delete, set null. Right? On delete, set null. අපි ඒවා කතා කරා මේ ළඟදි කතා කරේ හරි. On delete, set null, on delete, set default, on delete, cascade, on delete, restrict. Okay. So I'll go for E. Yes, C. Okay. E. Eighth question. Which of the What is the most appropriate reason to decompose a relation into multiple tables during normalization? So that is what we discussed today. Okay. Most appropriate reason to decompose relation into multiple tables. So that is to make it more consistent. Okay. Less redundancy and so on. To improve sorting performance and effectiveness, no. To eliminate insertion, deletion, and update anomalies, possibly yes, but let's see whether there's a better one. To ensure automatic indexing, no, there's no connection to that. To reduce memory consumption, not really. To allow unrestricted data access, no, that is related to the uh, security. Yeah, so I think the best out of these is to eliminate insertion, deletion, and update anomalies. So that is why we want to uh, make it little bit better by taking the fields into the correct tables. Okay, so I'll go for B. Yes, B. 9. Which of the following statements is used to remove? Now you can see the your maths paper was very hard, but I would say this paper is too simple. Usually database paper is much difficult, much difficult. So usually the database paper is the most difficult paper. Uh, According to my previous uh, experience, but it looks like this year database paper is super simple, right? Whereas the maths paper is super, right, super challenging, right? It has so usually database paper is very difficult, maths paper is easy. I don't know what happened next year. Okay, so far this is very easy. Which of the following statements is used to remove a table from a database? So that is drop table, right? Truncate also work, but truncate doesn't remove the table. It remove all the data. It drop and recreate. It drop and recreate. Delete will delete all the records till the table is there. So we want to remove the table. So then you go for drop table. Right? 9A. So this is kid stuff, right? මේ මෙච්චර මේව නම් මේ පොඩි ළමයින්ට දාන්නේ වගේ. ඒ ලෙවල් වල තාන මීටර් යමාරු question. Which of the following removes users access privilege in SQL? That is revoke. අයියෝ මේව නිකන් මටත් නිදිමත වෙනවා. 10C. හරි මේකට ගියොත් නයි tie ප්ලස් එකක් නෙමෙයි CNC වරන් එන්න ඕන. From among the following, what does system catalog keep track of? System catalog is another name for data dictionary that keep the metadata, data about data, or sometimes we call it design view in databases like access, table names, fields, what are the primary keys, foreign keys. Okay. From among the following, what does system catalog keep track of? Relationship between data in tables. Yes, right. We want to keep track of relationships, table structures, index structures also. Yes, right. What type of index? I'll say all. Right. I'll go for E. Yes, E. 12. The cardinality of domain D, where D is digits in the binary representation is, what is that? Cardinality of domain D, right? So cardinality of domain means how many possible values, where D is the digits in binary representation is, what is that question? That is a little bit confusing for me. Cardinality of domain where D is digits in binary representation. What are the digits in binary representation? 0 and 1, right? So digits in binary representations are 0, 1. Okay. So D is the digits in binary represent. I think we should treat it complete as separate, not separate. Digits in binary representation. What are the digits in binary representation? 0 and 1. Okay. So therefore, we have two possibilities. If you have two possibilities, so then cardinality must be, cardinality is how many possibilities? What are the possible values? Right? For example, gender, male or female, cardinality is 2. Cardinality of the domain is 2. But if it is something like marks, say marks can be 0 to 100, cardinality is 100. But if it is something like a price or something, cardinality can be anything, infinite possibilities. Okay. So therefore, I'll go for 2. Sorry, 2, that is C. Right? 12, I will go for C. Yes, C. Right? මම ඔයාලට පොඩ්ඩක් ඩබල් චෙක් කරු මොකද්ද මේ cardinality of domain කියන්නේ මම මතකින් කිව්වේ. මට මතක විදිහට නම් cardinality of domain කියන්නේ ඒ field එකට values කීයක් එන්න පුළුවන්ද? නිකමට අහලා බලමු ChatGPT එකෙන්. Just to double check, okay? Right. What is mean by cardinality of domain in databases? Theory. Cardinal domain is number of distinct values. Yes, number of distinct values. Okay. So if it is gender, male, female, other. If it is days of week, 7. Yes, correct. So therefore, because it says it's one of the binary digits, so therefore cardinality is 2. Right? Cardinality is 2. Right. So answer is correct. Okay. Right. 13th question. Which of the following is are components of the relational model? Right. Relational database objects, relational operators, relational constraints, relational memory buffers. That one I am not very sure. ඔන්න ඉස්සෙල්ලම ෆාසි ක්වෙස්චන් එකක් දීලා තියෙනවා කොහෙන් හරි ඔයාගේ රෙෆරන්ස් බුක් එකෙන් වෙන්නේ නැති ගොඩක් අයට. relational model. සාමාන්‍ය relational model එකේ මම නම් අහලා තියෙන්නේ relation tables, relationships ඔන්නෝවා තමයි. Relational operators. Maybe, right? Relational operators, maybe joins, right? Projections, selections. මම නිකන් දැන් ගෙස් කළා මට 100% මට මේක තියරි එකක් විදිහට මම ඉගෙනගෙන නැහැ. හරි? අපේ notes වල තියුනේ නැහැ UCSC note එකේ තියුණාද මතක නැහැ. හරි? But I will use my common sense. එහෙම කරන්න ඕනේ පළවෙනි question එක ඇත්තටම. So I'll go for relational operators. Maybe relational database objects like relations, relationships, and so on. Do we have 1, 2 only? No, you don't have 1, 2 only. Then maybe I will take 3 also, relational constraints also. Okay. Like primary key constraint, referential integrity constraints, entity integrity constraints. I don't want to take relational memory buffers because memory is not theoretical thing. This is relational model. Memory is more technical thing. So I'm not very sure. So usually relational algebra, relational theories, just like maths. So why do you want to think about memory buffers? So I'll go for 1, 2, 3. This is little bit of my common sense rather than confidently saying because I have not read this as a theory. Okay, I'll go for B. Let's see the examiner's answer. Yes, answer is B. Right. So remember, relational theory is more concept, theoretical thing. Memory buffer is not theory, right? It's technology. Right. So therefore, my guess C is correct. Actually, I guess it, and it's correct. Okay. 14. Which relational algebra operation is presented in the expression this is join or is it Cartesian product? Join උත් වගේ මෙහෙම ගොඩක් අර තියන්නේ. බලමුකෝ. R join no whatever is S equals sigma C R. This is Cartesian product. R Cartesian product S and then sigma using this condition. So here it says R join S using this condition. Okay. Right. A. Which relational algebraic operation is presented in the expression of this? And why is this identity useful? Identity useful. Okay. Natural join, filter based on schema matching attributes. Intersection, this is not an intersection. This is not a division. This is not really outer join. Ensures attribute type compatibility. Theta join, it decomposes join into primitive operations. That, of course, I have no clues. Okay, let's see the answer. I'm not very sure about that one. Okay. The examiner's answer is theta join. It decomposes join into primitive operations. So it has, this is a join based on this condition. So now what it has done is do the Cartesian product and then filter out based on the condition. So I think that is fairly okay because Cartesian product is a primitive operation. So primitive operations are sigma, pi, Cartesian product. Join is not a primitive operation. So maybe we try to convert our join into using primitive operations. That is Cartesian product and then filter out only related data. I think that uh, so theta join means a general term, right? Either it's use equal mark or uh, equal mark or relational things like greater than, less than. Okay, so commonly we call it theta join. So we discuss about theta joins. Okay, so therefore, I think the examiner's answer is fairly okay. Okay, I can agree. Right. So that is the first time I'm in trouble. So maybe I will not get marks for this one. Okay, if I go for the exam. Right, 15. Given an entity, student ID and name, where email is multi-valued attribute. Okay, so that means student ID, name, email, but email can be multi-valued. That means student can have multiple emails. What is the correct primary key for the resulting student email relation? So that is you take email to a separate table uh, in the relational model. So remember in the email or student email table, email will be a field, a student ID will be a foreign key. So then only we know that that email is related to that student. Okay. So therefore, we need student ID, email. You don't need name. You can keep name in the student table because this is student email. So therefore, not this. You don't need name. A student ID is not enough. So we can have student ID email as the composite primary key. Or you can have a surrogated primary key and keep student ID and email. Or student ID email is your primary key. So definitely answer must be D. Okay. අද කරපු එකෙන් හරි D. අපි කරේ මේක primary key එක කරන්නේ නැතුව surrogated key එකක් දැම්ම මතකද? දැන් මෙතන කරලා තියෙන surrogated key එකක් දාන්න නැතුව ඒ දෙන්න primary key එක කළා. එහෙම කරන්න පුළුවන්. Right. 16. Which of the following is an incorrect justification for creating separate table to handle multi-valued attributes? So separate table for multi-valued attribute means you make it first normal form, right? First normal form. Incorrect justification. Again, මෙතන correct justification හතරම තියෙන්න ඕන. To preserve normalization rules represent especially 1NF. That is correct, right? We want to preserve 1NF normalization. Second one, to eliminate redundancy caused by repeating groups. That is also correct, right? Repeating group what repeating group එකක් කියලා අහුවෙන්නේ මෙහෙමයි. මම ඒක උදාහරණයක් විදිහට ගත්තේ නැහැ වාගේ note එකට. I will explain it. මතකද අපි කර එකම ප්‍රශ්නේ රෝග ලක්ෂණ එක එක විදිහට එනවා කියලා. කොහොම පෝස් කරලාද? Let's take this. Right. So this is violation of first normal form. Right. So this is one form of the problem. Another form of the same problem is, right, you have something like this. I told you this is also the same problem, but someone has tried to give a solution, but that is not a good solution. Right? Right? Another person might like use something like this. One Ravi Fernando BSc and again one Ravi Fernando MSc. That is also not the solution, right? So the solution is you need to take this to a separate table. A separate table. The repeat table you can repeat බොරුවට. Right? So therefore that is not the solution. Okay, that is not the solution. So therefore I will take that also as correct answer. Correct answer. C. To support many-to-many relationship between entities. So when we have many-to-many relationship, yes, we need to create a separate table. Okay. Which of the following incorrect justification of creating a separate table to handle multi-valued attributes? But multi-valued attribute and many-to-many. Many-to-many also the same problem is there, right? We otherwise we will end up as multi-valued attributes. Okay. So payments, payment for BIT, payment for FIT, all those things will be there. Yeah. So anyway, this is not directly related to first normal form because this is more related to how to design your many-to-many relationship, but indirectly that problem is there. Therefore, just let's keep it. If nothing is there, we will take this as incorrect. Okay. To allow flexibility in storing variable length fields. Variable length. Variable length means that field can have different size, right? For example, name can be a small name like Nimallo, right? Arachilage, don't, blah, blah, blah. And variable length here, right? But variable length and multi-valued is not connected. That's a different story. So therefore, I don't think that this variable length field has anything to do with the multi-valued attributes. Right? Uh, that's a different story, different problem. To simplify indexing on atomic attributes. Atomic attributes. Index එකක් හදන්න පුළුවන් වෙන table එකකට දැම්මම. Right? To speed up the retrieval. Right? So that is if you add it to another table, when you have multi-values, you can't create indexes. So therefore that is also indirectly correct. මේකට අමාරුයි මොකද correct ඒවා ගොඩක් තියෙනවා කියන්නේ definition එකේ කෑලි විතරයි මේවා ඉන්නේ. මට ගොඩක් කාට මෙන්න මෙයා තමයි සැක. මොකද මෙතන කතා කරන්නේ variable length field ගැන. variable length field කියන එක කොහොමත් first normal form එකට අදාළ නැහැ. variable length field කියන්නේ අපි field එකේ ඒ කියන්නේ අර වාචා කියන එකක් තියෙන variable character fixed character වෙනම තියෙනවා. හරියටම මෙච්චරයි. So therefore I'll go for D because this is D is relevant. විතරක් අර many to many වලත් repeating groups වගේක් එනවා. ඒ කියන්නේ අපි කඩලා table එකක් දාලා. So therefore I'll go for D. Okay. It's a bit of a guessing. 16. Yes, answer is D. Okay. Answer is D. Right. 17 to 21, we need to use this. Right. An online art gallery system tracks artists, their artwork, and exhibitions in which artwork are showcased. Okay, artworks are showcased. In the given database schema, the artist table acts as parent to artwork table, where each artwork is created by a specific artist. Right. So each artwork is created by specific artist. That is why we have the artist ID as a foreign key. Okay. Forming a one-to-many relationship. Okay. So that means between the artist and artwork. Let's because make a question හතරක් පහක් තියෙනවා පොඩි වෙලාවක් අරගෙන කරමු. But it's a word. This is artist. This is artwork. And this is one-to-many relationship. One artist can have many artwork. One artwork belong to one artist. Similarly, the artwork table serves as parent to exhibition table. Okay. ඒ කියන්නේ artwork ID එක තියෙනවා foreign key එක විදියට. That means one artwork can go into many exhibitions. Okay. Many exhibitions. Exhibitions. කියන්නේ ඒ artwork එක exhibition කීපයක පෙන්වන්න පුළුවන්. වෙන වෙන කාලවල වෙන්න. හරි. That is one to many. Many side is this. Many side එකේ තමයි foreign key එක යන්නේ. Okay. Similarly, artwork tables serves as a parent for the exhibition table as each artwork can appear in multiple exhibitions. Yes. මෙච්චර explain කරන්න වෙන අවුරුදු වල. හරි. මෙහෙම explain කරන්න මට table තුන විතරයි දෙන්නේ. හරි. ඇත්තට මේ පාර examiner හරිම කරුණාවන්ත examiner කෙනෙක්. හැබැයි කරුණාවන්ත උනාට tough මදි දැන් paper එක. හරි. These relationships are enforced using foreign keys. Artwork dot artist ID ඔච්චර කියන්නේ මොකටද ඕක පොඩි ළමයින්ට artwork dot artist ID references artist dot artist ID and exhibition dot artist ID reference to artwork මේ මෙච්චර මේවා කිය ඇත්තට මේවා මුකුත් කියන්නේ නැහැ වෙන අවුරුද්දවල හරි අනිවාර්යෙන් වෙන එක්සැමිනර් කෙනෙක් හදලා තියෙන මේවා කියන්නේ නැහැ ටේබල් තුන විතරක් දෙනවා හරි හරි දැන් පොඩි කාට වගේ එක්ස්පීරියන්ස් කරා දැන් ක්වෙස්චන් ටික බලමු Which of the following SQL statement correctly create exhibition table including the exhibit data and location? බලන්න ඔයගොල්ලන්ගේ examiner මාරු වෙලා ඇති බොහෝ විට. මේ වගේ question එක දෙන්නේ නැහැ නැත්තම්. හරි. So it's I'm just curious. හරි. පවා වගේ question එක දෙනහම සමහරට lady කෙනෙක්ද කියලාත් මට සැකයක් හිතෙනවා. like post coordinate. So ඒගොල්ලෝ දැන් ගොඩක් අර මෙච්චර හුරතල් කරලා paper එක හදන්න. Let's see whether the examiner has changed. සාමාන්‍ය database paper එක පුදුම අමාරුයි. පුදුම අමාරු paper එකක් දෙන්නේ. අනිවාර්යෙන් examiner මාරු වෙලා තියෙනවා. post coordinator මාරු වෙලා තියෙනවා. ඒක මට හිතෙනවා. හරි මට I can't say exactly. දැක්කනේ. I facility මේ පේනවද Mrs. JEL චතුරංගනි. කලින් හිටියේ එහෙම කෙනෙක් නෙමෙයි. right කලින් හිටියේ එහෙම කෙනෙක් නෙමෙයි. post coordinator මාරු වෙලා කියලා මට නිකම්ම guess කරන්න පුළුවන් වුණා paper එක කියවද්දි. හරි. so ගොඩක් අයට ඉන්නේ ડોක්ටර් කෙනෙක් හරි maths paper එකේ න අනිවාර්යෙන් professor කෙනෙක්වත් ඇති. පේනවද මේ paper එක පට්ට අමාරුට හදනවනේ. Pushpanand, Dr. Pushpanand. Web, yeah, දැක්කද? database paper එක හදලා තියෙන ડોක්ටර් කෙනෙක් නෙමෙයි. හැබැයි ડોක්ටර් කෙනෙක් නොවන පරිදි paper එක ලේසි කරන්නේ නැහැ. හැබැයි බොහොම මං හිතන්නේ බොහොම ඔයගොල්ලන් කෙරේ කරුණාවෙන් දයාවෙන් හදපු paper එකක් කියලා මට තේරෙනවා නිකන් කියවගෙන නැති සාමාන්‍ය database paper ඔහොම නැහැ. හරි? ඒක මම මේ ගිහලා double check කරේ හදිස්සියෙම මේ කවුද lecturer කියලා. කලින් හිටියේ වෙන ડોක්ටර් කෙනෙක්. හරි? paper මාර අමාරුයි. මොකද මේ වගේ කියලා කියන්නේ හරි නිකම්ම table structure එක දෙනවා. හරි? right anyway. Which of the following SQL statements correctly එහෙම තමයි යුනිවර්සිටි වල හරි යුනිවර්සිටි වල කල්චර් එක තමයි ලෙක්චර් මාරු වෙච්ච ගමන් සබ්ජෙක්ට් සම්පූර්ණයෙන්ම papers ලේසි papers අමාරු වෙනවා අමාරු papers ලේසි වෙනවා මොකද ඒවයි මේ A level paper එක වගේ නෙමෙයි හරි යුනිවර්සිටි වල ලෙක්චරර්ස්ට ලොකු powers තියෙනවා හරි ලෙක්චරර්ට ඕන විදිහට තමයි ලෙක්චරර් paper එක හදන්නේ කවුරුත් අනිත් ඇවිල්ලා අත ගහන්න ඉන්නේ නැහැ ලේසි හරි ඒක ඇවිල්ලා යුනිවර්සිටි එකේ තියෙන කල්චර් එක. ඒක යුනිවර්සිටි වල ඒක හන්දයි සමහර යුනිවර්සිටි හොඳ සමහර යුනිවර්සිටි නරක කියන්නේ එච්චරම පිළිගන්නේ නැත්තේ. ඉතින් ලෙක්චරර්ස්ලාගේ පර්සනැලිටි එක තමයි යන්නේ. හරි. මම කියන්නේ මේ පේපර් එක නරකයි කියලා. මම කිව්වේ මේ පේපර් එක ටිකක් මෘදු විදියට හදපු පේපර් එකක්. හරි. අර දැක්කනේ මැත්ස් පේපර් එක නේද? මේ මැත්ස් පේපර් එකේ තනිකරම හදලා තිනවා කරකෝල අතාරින්. හරි. බොහෝ විට මැත්ස් පේපර් එක හදපු ලෙක්චරර්ත් මාරු වෙලා තියෙනවා කියලා මට හිතෙනවා ගිය අවුරුද්දේ. මොකද සාමාන්‍ය මැත්ස් පේපර් එක එච්චර මාරු නැහැ. හරි. එච්චර මාරු නැහැ. right. So which of the following SQL statement correctly create exhibition table including the exhibit date and location while maintaining proper referential integrity? Okay. Right. Exhibition table. So you need to have the exhibit ID, primary key, artwork foreign key, then exhibit date and location. Okay. exhibit ID චා දාන එක නම් හොඳ නැත. චා දාන එක නම් හොඳ නැහැ. int වත් යන්න ඕන. හරි මේවා int ගිහිල්ලා තියෙනවා. And also primary key, that is good. Primary key. Here no primary key, right? මෙයාගේ primary key එකක් ඇත්තේ නැහැ. එතකොට මම මෙයාව ගන්නෙ නැහැ. මෙයාගේ primary key එකක් ඇත්තෙත් නැහැ. මෙයාගේ no primary key here. Okay, so therefore I will not take this. What about this? So here no foreign key, right? No foreign key. So foreign key is artwork ID, referring to the artwork table, right? Artwork table, reference to the artwork ID, reference to the artwork table, artwork ID. ये देखना समान है, right? Foreign key, artwork ID, foreign key, artwork ID. Primary key also the same, exhibition ID. Then artwork ID in, that is also the same. Exhibit date 8 කියලා එකක් නම් මම දන්නේ නැහැ. එහෙම එකක් තියනවාද කියලා. date 8 කියලා. Location vacha 50. So only difference is here it says date 8. So usually the size is related to vacha fields and in number fields and decimal places here. So therefore I won't take this because මට පේන එකම වෙනසක් ඔය 8 කියලා තියෙන විතරයි මේ දෙකේ. හරි. So therefore I'll go for D. Right. 17 I'll go for D. Yes, answer is D. The date වගේ fields වල මෙහෙම 8 කියලා දාන්න හේතුවක් නැහැ. නේ. මොකද එච්චරයි වෙනසක් නැති වෙන්නේ මේ දෙකේ. Right. 18. Which of the following will return the average price of artworks by each artist? Group by කරන්න ඕන. List from highest to lowest. Right. List from highest to lowest. Average price of artworks by each artist. එතකොට අනිවාර්යෙන් group by කරන්න වෙනවා. Here no group by. Group by නුකරෝ කරන්න බෑනේ. So here we have the group by artist ID, group by artist ID, group by artist ID, group by artist ID. Okay. Then listed from highest to lowest. That is, we are calculating the average price, right? AVG price. Make online number. AVG price. Do we have AVG price here? Select artist ID price. No. Make හරියන්නේ නැහැ. You need to calculate the average price. Right? Average price. Here you get the sum and divide by count. Sum එකෙන් count එක බෙදුවත් average price එක එනවා හැබැයි. Average price එක එනවා. Okay. අපි එක එක බලමු නැත්නම් මේක පැටලෙනවා. Select artist ID and average of the price from artwork. Okay. Group by artist ID. So far, so good. Order by, again, average price in descending. Listed from highest to lowest. So that looks okay. Simple and short. වැඩේ නම් වෙනවා. Right? From highest to lowest, that is descending order. මේක නම් හරි වගේ. දැන් බලන්න මේවයි වැරද්දක් තියනවාද කියලා. Select sum of price divided by count star. ඒකම තමයි මෙතනත් කරලා තියෙන්නේ. Sum of price divided by count star. ඒකත් අපි හරියන්න ඕන නේද? From artwork. ඉතින් එහාට වෙනසකුත් නැහැ. ආයිමත් තියෙනවා group order by sum of price divided by count star. මේක ටිකක් over engineering හැබැයි. මෙතන order by කරලා තියෙන price එකේ. ඒකන්ද මේක කොහෙවත් වෙන්න බෑ. order by කරන්න ඕන average price එකට. Right? මේ දෙක තමයි දැන් ඉතුරුලා තියෙන්නේ. Here we use the average price. Very straightforward. Because AVG is a function. But here you take sum of the price divided by count star එක හරියට එයිද කියන ප්‍රශ්නකුත් තියෙනවා. Anyway, only one answer we need to take because this is simple solution. I am not very sure about this, but it looks somewhat okay. I'll go for B because this is very straightforward, correct. Okay, I'll go for B. Yeah, answer is B anyway. Answer is B. මේක වැරදිද මට තේරෙන්නේ නැහැ. හරි. සමහරට හරියන්නත් පුළුවන් වරදිනත්. මේක ඉතින් හරියන එකක් තියෙනවා තමයි ඒකට යනවා. හරි. හරි. ඕනනම් මේක එක ටේබල් එකක් හදලා පොඩ්ඩක් ගහලා බලන්න මේකත් හරියද කියලා. හරි. 19. What is the error, if any, in the SQL statement given below intended to change the size of price column into column in the artwork table from decimal 8.2 to decimal 10.2? Okay, 10.2. What is the error? Modify කියලා නම් ලියන්නේ නැහැ. හරි? Set කියලා තමයි ලියන්නේ. Alter table artwork. Okay. Alter table artwork. ඒ මොකක්ද ඉතින් set කියලා නෑනේ මේ කොහෙවත්. Set නෙමෙයි alter table artwork. මොකද alt එක ලියන්නේ? alter table artwork මතකත් නැහැ එකපාරට ඔළුවට එන්නේ නැහැ. කොහොමද අපි note එක අරන් බලමු මට field එකක් වෙනස් කරේ කොහොමද? Anyone can remember? Let's take our note. SQL. alt කියන උඩම. right. change column නේ. change column කියලා column එකේ පරණ column එකේ නම දීලා පරණ name එක අලුත් name එක. සහ ඊට පස්සේ අලුත් data type එකට අදාළ දේවල්. name කියන එක change කරන්න depth name කියලා. ඒ අතර වල data type එක වෙනස් කරන්න පුළුවන්. change column කියලා එනවා. හරි. change column. but change column කියලා එකක් නැහැ නේ මේකේ. modify කියලා දී. හරි වැරද්දනේ අපෙන් අහන්නේ. alter column නෙමෙයි. alter is here. alter table column. Syntax is valid only if the column contains no data. එහෙම අවුලක් නැහැ මොකද මේකට වැඩිය මෙයා ලොකු type එකක්. 8.2 වඩා 10.2 කියන එක field එක ලොකු වෙනවා. field එක ලොකු වෙනකොට ප්‍රශ්නයක් නැහැ. There is no errors in the SQL. No, මෙහෙම modify කියලා එකක් නැහැ. I don't know. Right. It should be change column. Okay, change column. Change column කියලා උත්තරයක් නැහැ. What is the examiner's answer? 19. Examiner has given marks to all. I think because the change column is not there. This should be change column. All column name, new column name, and new data type. Column name එක වෙනසක් නැත්නම් ඒත් කමන්නේ. දෙපාරම ලියන්න එකම column name එක. Value data type එක ලියන්න. So it should be change column, okay? Not alter column or whatever. I think that is why examiner has given marks to everyone. Okay? Marks to everyone. Okay, so therefore let's move on to the next question. 20. Which query given below returns only those artists who have created at least one artwork? If there's only at least one artwork only, we need uh, that data. Okay? Outer join, outer join, outer join, outer join එක කරන්න ඕනද මේකට? Here no outer join. Okay? Select distinct name from artist. Only those artists who have created at least one artwork. So artist table එක මොනවද තියෙන්නේ? Artist table, artist ID, name, country, birth date. මේකෙන් අපිට මුකුත් කරගන්න බෑ. Artwork එකක් තියෙනවද කියලා බලන්න බෑනේ artist table එකේ. Right? So therefore from artist table alone you can't get these details. So therefore I will not take A. Right? I will not take A. Okay? Because artist table එකෙන් හොයන්න බෑනේ artwork එකක් තියෙනවද කියලා. So therefore we need to refer to artwork table also. There your artist ID must appear at least once. මෙන්න මේකේ artist ID ඉන්න ඕන. එකපාරක් හරි ඉන්නවා කියන්නේ එයාට artwork seal. හරි. දැන් ආයි බලමු. So therefore anyway we need to join. Right? Outer join, left outer join, right outer join, full outer join. Full outer join කියන එක අපි MySQL වල ගහන්නේ left outer join union right outer join කියලා. සමහර database වල full outer join දෙනවා. ඒ කියන්නේ both left and right. හරි? full outer join එක නම් ගහන්න ඕමනාවක් නැහැ. කොහෙත්ම because then you get artworks having no artist as well. එහෙම එකක් තිබුණොත් possibly left outer join, right? Not right outer join. අපබල මෙයා හරිද කියලා දැන් select name from artist, left outer join artwork, only those artists who have created at least one artwork. At least one artwork na left out join narang hariyanne naha. Left out join means we take all the artists, right? That is what is meant by left out join. Whether there's artwork or not, you get the artist. So therefore I don't think left out join also will work. Right out join, what is this one? මෙයා මොන join එකක්වත් නැහැනේ. Left උත් නැහැ, right උත් නැහැ, නිකම්ම join. Select name from artist, join artwork on artist ID equal blah blah blah. ඒක නම් මට හිතා ගන්න බැහැ. Who have created at least one artwork. මේ තියෙන queries තුන මට තේරෙන්නේ නැහැ. Anyway, what is the answer? E. නිකම්ම join කියලා ලියලා තියෙන්නේ. නිකම්ම join කියලා ලියන්නේ කොහොමද? Is it a inner join? නිකම්ම join කියන්නේ නෑ inner join වෙන්නේ නැති. Okay? නිකම්ම join කියලා inner join වලට ගත්තේ. Okay, let's look at inner join. අපි inner join කියලා ලිව්වනේ. නිකම join කියලා ලිව්වේ නැහැ කොහෙවත්. left join, right join, full join කියන එක අපි ලිව්වේ left join union right join කියලා. But we never use just the word join, right? Full outer join, uh, you can say left join union right join. Okay. මේක නම් මට තේරෙන්නේ නැහැ. පොඩ්ඩක් අපි chat GPT එකෙන් අහලා බලමුද? Alexa ask chat GPT. අද මේ join කියලා ගහන්න තියෙන්නේ කියලා මට තේරෙන්නේ නැහැ. Okay, so shall we put it into the chat GPT? Fussy question on ඉඳලා ඉట్లా එකක් දෙකක් තියෙනවා. එයා කියන්නේ join කියලා ලියන්න කියලා තමයි. Why regular join? Regular join is the inner join. Right? Inner join means if there's a connection. I think, yeah. So my confusion was the word inner was not there. So chat according to ChatGPT, if just say join, it's a inner join. Okay. හරි inner join යන හරිනේ. relation එකක් තියෙනවා නම් තමයි ගන්නෙ. හරි. Returns only rows where there is a matching record in both tables. Yeah. So that means if you have a artwork, only that artist is taken. Okay. Right. So that makes sense. Right. So just make a note of that. If you have just join, that means inner join. Okay. So just make a note of that. Because now I was looking for inner join because it can't be left join, right join, or full join. So basically join means inner join. Inner join කියන්නේ එතකොට connection එකක් තියෙනවා නම් විතරයි ගන්න ඕන. Right. That is correct. Okay. Which query will give below return only those artists who have created at least one artwork. මෙතන තව පොඩි හොඳ වැඩක් කරන්න තිබුණා. Right, we can make this better. පොඩි වැඩක් කළා. ඒ තමයි මොකද්ද? මෙතන එක ඒ ආටිස්ට් කීපයක් තියෙනවා නම් ආර්ට් වර්ක් එයාව දෙතුන් පාරක් එනවා. මේ query. ඒක නවත්තන්න විතර මෙතන distinct කියලා දැම්මනම්. right, distinct කියලා දැම්මනම් එතකොට ඒ ආටිස්ට් මේ මෙන්න මෙතන නම් distinct කියලා දාලා තියෙනවා. එතන කතන්දරේ වැරදි. So that would have been better. හරි. එතකොට යාට දැන් ඒ ආටිස්ට් ආර්ට් වර්ක් පහක් තියෙනවා මේ query ට අනුව පස් පාරක් එනවා. පස් පාරක් එනවා. So therefore, this query is okay, but it's better to use distinct. Okay? අපි ChatGPT එක අහලා බලමු මෙහෙම කරොත් හොඳයිද කියලා. මට නම් හිතෙන්නේ එහෙම කරොත් තමයි මේක වැඩි සාර්ථක. Why the others are wrong? හරි. අනිත් අය වැරදියි කියලා කියනවා. So I will ask, don't we need distinct keyword? නිකමට අහලා බලමු. Right. In practice, yes. Yeah, you can say in practice, yes, you may need distinct depending on what exactly is being asked. Okay. මොකද නැත්තම් දෙපාර එනවා. Okay. හැබැයි ඉතින් දීලා තියෙන answers වලින් හන්ද ඉතින් chat GPT එක ගැන හිතුවේ නෑ. හරි. Uh, so therefore uh, so conceptually correct answer is E. Production quality query, the list artist once use distinct, right? Production quality code එකකට ගියොත් අර තන distinct කියන එක ගන්න නැත්නම් අර එකම artist දෙතුන් පාර එනවා result එක විදියට. හරි. So therefore that is fine. So this answer is okay, but ideally we should have the distinct keyword also. Okay. Right. 21. Which SQL statement gives only permission to update the price column in artwork table to user amal. ඒතර grant update කියලා කියනවනේ මොන field එකද කියලා. column කියලා කියන්නේ නැහැ. වරහන් ඇතුලේ තමයි කියන්නේ සාමාන්‍යයෙන්. හරි. column කියලා කියන්නේ නැහැ සාමාන්‍ය standard SQL වල. grant update on artwork.price to amal. Grant update price on artwork to amal. Grant update within bracket price on artwork to amal. කොහොමද මේක ලිව්වේ මට නම් මතක නැහැ එකපාරට ඔළුවට එන්නේ නැහැ. අපි ඒ වගේ examples නම් කරා. හරි. That is security, right? Data normalization. Right. Security. Exact syntax එක I think grant update on employee salary field. Okay. To this හරියට මේ පොලේ තමයි දිගන්නේ. Right. Grant update on table within bracket field. Remember? Grant update on table within bracket field. Grant update on table එහෙම එකක්වත් නැහැ. Table එකේ වරහන් ඇතුලේ column කියන ඒවා ඉන්න බෑ කොහොමද? හරි. මේක වෙන්නත් බෑ. මෙතන table එක නැහැ. on කියලා එන්නේ නැහැ නේද field එක. on කියලා එන්න විදියක් නැත. on කියලා එනවා grant update on table within bracket field. Table within bracket field. මේක හරි හැබැයි price එක එනවනේ මෙතනට. මේක හරි artwork within bracket price කියලා ආවා. මේ දෙක කොහොමද වැරදි? මේක වෙන්නත් බෑ. dot පාවිච්චි කරන්නෙත් නැහැ. I don't know. I'm not very sure about this. Okay. What is the examiner's answer? 21. C අරන්ති. C මේ අරන්ති. මෙතනට දානවද? නෑනේ දාන්නේ මේ මෙන්න මෙතනට එන්න ඕනේ නා. on artwork bracket price. අන්න එහෙම එන්න ඕන. Anyway examiner has taken C අපි ChatGPT ගාමු එකක්. Maybe little bit non standard SQL එකක් ලියලා දෙන්න. ChatGPT ගොඩක් අයට ළඟින්ම යන එක විදිහට C ගණිත දන්නේ නැහැ. බලමු. අහලා බලමු. ඔයා C තමයි අරන් තින්නේ. එයා කියන මෙහෙම ලිව්වට කමක් නැහැ. update price on artwork. ඔව්. එහෙම ලියන්න පුළුවන්. Okay. Grant update this field on this table කියලා ලියන්න පුළුවන්. Price on artwork to amal. එතකොට අපේ example එකේ තියෙන විදිහ වෙනස් හැබැයි ආ. I'll double check. Okay. මම බලන්න මගේ note අපේ note එකේ syntax එක වරද්දලා දීලාද කියලා. හරි. අපේ note එකේ වරද්දලා දීලා වෙන්නත් පුළුවන්. Okay. Because in our note it's slightly different. Okay. අපේ note එකේ මෙතන තමයි දාලා තියෙන table එකේ නම දාලා මෙහෙම දාලා තියෙන්නේ. Okay. I will double check this. Okay. So therefore ChatGPT also says examiner's answer is okay. Okay. Right. So we'll stop at this point because I told you that we are going to stop at 9. Okay. Uh, so now you have a good start for this step, database subject. Uh, right. So this database subject, it looks easy. So therefore, make sure you spend a little bit more time for the maths, assuming that this year also the same data examiner will set the maths paper. නැත්තම් maths subject එක මං හිතන්නේ සමහරුන්ට පාස් වෙන්නත් අමාරු වෙන්න ඉඩ තියෙනවා. රිපීට් වෙන්නත් ඉඩ තියෙනවා. ඒ වගේ පේපර් එකක් දුන්නා. හරි. maths එක නම් and of course database is not very difficult. ඉන්දරයිට් ලේම question එකක් එන්න පුළුවන් නේ. හරි. එහෙම නැත්නම් මේක පේපර් එක මෙලොවම ගහක් නැහැනේ. හරි. Right. So we'll stop at this point, right? Thank you.